All right, now that we have a plan, let's start implementing the cryptography. So I just have this open in an empty directory. I'm calling mine UTFS file crypto. You can call it whatever you want. The first thing we're going to need to do is get our constants for this. So the constants, we can probably find them in the original author's example code. Expand 32 byte K. So we're going to want that as a static UN8 array. So let's go ahead. I'm just going to call it XCP for X cha cha 20 provider. What are we going to need? The first thing we're going to need, well, we're going to need probably the header for this. We will call the same thing just with the .h extension, and we'll also need string for memcopy. So the first thing that we're going to want this as is the sigma variables. So our static constant uint8, and this will just be, he calls it cha-cha, so we can call it cha-cha or sigma as well. And this will have 16 elements for our index. So what's that? So what is it, 61? Or little endian. It'll be 65, 78, 71. So these are all just the byte representations. And then we don't have to do it like this, but to me it makes it more legible to break it up into a four column, 4 row setup here. No, 0x. Okay, so we have our constant array down now. The next thing that we're going to need to do is we're going to need functions that turn, we're gonna have 32-bit little endian words. So we're gonna need the ability to turn 4 bytes into a word and the ability to turn a word into 4 bytes. So because these are 32 bits, we'll use a uint32 data type. I'll just call this, we'll append with XCP so that we never have any symbol conflicts with any other modifications or additions somebody may make to this file system. And we just need to take in 4 8-bit elements, right? Yes. So we will just be taking 8 u int 8t. Just call that our source, and that 4 is going to be A, B, C, and D, or 4 elements. You can call them whatever you want. You may not want to confuse them with the quarter round, but, and I'll just go ahead and type this function out. So we're going to want to cast these 8 bits into the 32 bits. So we're going to cast into a uint32. We're going to cast source with index 0. And then we're going to cast the next element, but we need the, like that. Oops. And then we'll repeat that for element. Let's see. Brackets, yep. And it's 24. And this one will be 3. Okay, so basically what we're doing here is taking, we need a 32, let's say this is 32 bit. So you could think of this as having 32 of these little boxes inside of it that are zeros or ones. And we are taking 8-bit inputs and casting them in here. So when we're doing that, if you just think of that as 8, that is 8, that is 8. So each of these are one 8-bit segment, or if you want, we can just say you divide them up like that. Let's do 4, 5, 6, 7. Yes, okay. This looks terrible, but bear with me. So you might have like 0, 1, 0, 0, 1, 1, 1. So what we're doing with this is we are casting these 8-bit pieces into this part of the 32-bit wide data type. Now we also want to do the opposite. We want to take a big one of these and split it out into 4 separate 8-bit words, 8-bit bytes, because a word is not 8 bits. So then we're going to want to split this back out into 4 different areas. So let's go ahead and do that now. So we are giving it 4 places to put 8 bits, and then we're giving it the value that we actually want to do this with. So for the first destination, we will cast the first value, or the first 8 bits of the value. And because we are casting, this will, don't forget your semicolon, this will concatenate, no, not concatenate, it will cut it off at 8. So you'll only get the first 8 in this. But when we go to the second one, we don't want to start at the beginning of that block again, because if we start at the beginning, we will just write the same data. So we want to cast value, but we want to move it forward by 8 bits so we don't repeat that same portion. And just like for the load, we're just going to repeat this process. Okay, we have our load and store functions done now. Now we just need our rotate left function. So our rotate left function, we are just going to take the value and rotate it by the count. So again, because the data type we are working with is going to be 32 bits, we need a 32-bit wide one. We'll call this our XCP rotate left 32. We're using a 32-bit value here. And then we just need the count, and that'll be an unsigned variable because the count shouldn't be negative. And we will just return something of 32-bit size, which will be the value of yes, open, close. Yes, okay.